Hello, you absolute legends. One of these solutions is not like the other. They are both solutions of water, but one of them contains sucrose. They will no longer boil or freeze at the same temperature because of this added molecule. This coagulative property, melting point depression, let's discuss. On the board here, we have an atomic vision picture of solutions of water. Now, in these atomic vision pictures, I've explicitly drawn a Lewis dot structure of the water molecule to just try to squeeze down our atomic vision here of just the solvent. Now, this one only contains water, so there's nothing else drawn. This one contains sucrose. Now, sucrose is a disaccharide that has like 2 6-carbon rings. So I'm trying to draw that little dumbbell looking thing to represent the sucrose molecule. These dotted lines are meant to represent interactions between the sucrose and the solvent right here. Now, this picture here is not like, this is cartoony with a little bit of detail. But nevertheless, there are interactions that exist here that don't exist here. Because of these interactions, the melting point will be depressed or lower than pure water. Our answer is going to be below 0 degrees Celsius. So let's make that note. Pure water boils up. Pure water freezes at 0, and freezing point depression is going to be a final answer below 0 degrees Celsius here. A couple other things about this solution that we need to put in our shopping list right here. We had 40 grams of sucrose present. And I'm going to put that in red because sucrose is in red. And 335 grams of water. I'm going to write that in blue because water is drawn in blue. We want our final answer in degrees Celsius, and nothing in here has degrees Celsius in it right here. Aw, Snickers. So the freezing point depression behavior of water is linear with a rate of, and this is a number that you have to Google about water, it is 1.862. So this is a physical constant of water that you have to Google, look up, or be given. And this is specific for the freezing point depression. Temperature is in there, and molality. Molality sucks as a unit. It sucks as a name because it doesn't tell you what it is. Molality is moles over kilograms. So let's accordion this out here. Now, when it's moles over kilograms, pause it and convince yourself that I expanded this out appropriately with what's in the numerator and the denominator. When we have 2 units like that, moles and kilograms, we need to talk about what is going on here, like what we're talking about here. Now, the degrees Celsius, I hope is pretty simple that we're talking about freezing point. So it's going to be like a thermometer stuck in here, the temperature of the whole solution. Kilograms. Kilograms of what? Moles of what? Moles of water? Moles of what? Moles of glucose. Excuse me, moles of sucrose. Moles of solute. Kilograms. Kilograms of water. This needs to be clearly identified and stated before you kind of move on right here, because it depends on how we patch things up here, okay? For example, this is a common error because it looks too good to be true, right? Grams to kilograms, but my colors show that that would be not the best thing to do. We want our final answer, degrees Celsius. This thing's got degrees Celsius in the numerator already, so I'm going to make a smart start with that. Remember, this is the freezing point depression physical constant for water, so it's something that was either given to me in the problem or I Googled it. And there's another one of these for if you do a problem on boiling, don't use this number, only for freezing. I need to cancel out these units here. And I want to protect this degrees Celsius because that's what I want my final answer. Kilograms of what? Kilograms of water. Oh, bingo. I'm already given the grams of water. 335 grams of water. Cross it off my shopping list once I put it in the scaffold. These units don't cancel quite yet, but they are cousins. 1,000 grams is 1 kilogram. That's a true statement from here to Mars. And beyond. Grams also cancels out. So the kilograms of water is canceled out using numbers about water. The moles of sucrose needs to be canceled out with information about sucrose. Now, here's where I got to dig a little bit. It's grams of sucrose and moles of sucrose right here. There's a unit that combines both of them as a fraction, the molecular weight. Of sucrose, 392.3 grams divided by moles. I need moles to cancel, so 392.5 grams divided by moles. And it looks like I put that in there upside down and funny. Why I did that was from the half-court shot of moles canceling out moles. Now this is where things really start to click into play. I only have one thing left in my shopping list, and it matches the one thing I need to do. So I'm going to plug that into my scaffold. I'll have used everything in my shopping list. I'll have the only unit left in my scaffold that my answer is looking in. And remember, this is freezing point depression. So your answer will tell you how much the freezing point is depressed. So you need to take the freezing point of the pure solvent and subtract your answer to get the depression. I hope you have a happy day. Thank you.